All right, last part. Excuse me. Now we got to do number 58. Oh, we do have to do number 62. Yeah, so. All right, so we're calculating the density of these guys. Ooh, density. Oh, we did that in notes, didn't we? Where we talked about that density is grams over liters, right? So in order to do this, we need the molar mass. We need that double question mark guy. And then the liters of a mole is 22.4. So really all we got to do is we just got to figure out that molar mass of that substance and put it in here. So the first one we got propane, C3H8. So C3H8, stop and talk. So we got 3 carbons times 12 plus 8 hydrogen times 1. So that's 36 plus 8, so that's 44. So we're going to go 44 grams divided by 22.4 liters. And if you divide that out, you're going to get a density of 1.96 grams per liter. Okay, let's find out something. Remember way back when we talked about the density of the nitrogen in the room, which happened to be 28 divided by that. I think it was 1.25 grams per liter. That's the density of the air in the room. So where's propane going to go? Oh, it's going to go down. It's going to be at the bottom of the room because it's going to sink because it's more dense than the air. All right. Now we go to the next one. Next one we have is neon. So neon, there's only one of them times his mass is 20. So that really gives me 20 grams of neon per divided by 22.4. So that gives me 0.893 grams per liter. So where's neon going to go if I release it in this room? It's going to float up because it's less dense than the air that's in this room. Because remember, that's the density of the air that's in this room. This is less dense. All right, let's go to the last one. NOS. Those of you that mess with cars, hold on one second. All right, so my next one was NOS. For those of you that work on cars, this would be the kind of stuff that you can put in your car, make your car go really fast. Or if you watch Fast and Furious, and they have a little button that they press, and all of a sudden their car like flies like crazy. That's be the stuff nitrogen dioxide. And that increases the oxygen to the motor, which gives me more energy out of the gas that I'm using. So just some extra information there. So we got 1 nitrogen times 14 plus 2 oxygens times 16. So that's 14 plus 32. So that's 46. So 46 grams divided by the 22.4. So we divide that out, I'm going to get 2.05. And that's grams per liter. So 2.05, where's that going to go if I release it in this room? It's going to sink because it's more dense than the 1.25 that this room is made up of. All right, so that concludes that one. All right, now we go to the calculate percent composition one. I think it's number 60, right? Yep. So we're going to calculate the percent composition of each compound. So I've got H2S. So in order to do this one, figure out his molar mass. It's 2 times 1 plus 1 times 32. My eyes are itching. So I'm going to go, this is 2 plus 32. So that's 34. So now to figure these guys out, if I figure my H, well, he supplies 2 out of the 34 times 100%. And the S supplies 32 out of the 34 times 100%. So if I divide those guys out, I'm going to get the hydrogen supplies 5.88% of the is hydrogen, and 94.12% of it is sulfur by mass. All right, so I'm really just using the molar masses in order to do this. All right, let's go to B. Letter B, we have a whole bunch of them. We got NH42 and C2O4. Oops, I don't need the parentheses there. C2O4. All right, that's a whole bunch of stuff there. So we add this up, there's 2 nitrogens times 14, plus I got 8 hydrogens times 1, plus 2 carbons times 12, plus 4 oxygens times 16. Goodness, All right, so this is 28 plus 8 plus 24 plus 64. Add all those guys up, and you're going to get, it's 124 total. So I'm going to go for the first one. For nitrogen, we're going to go 28 divided by 124 times the 100%. And then my hydrogen, we're going to go, he supplies 8 grams out of the 124 times the 100%. Then I hit carbon, he supplies 24 grams out of the 124 times the 100%. Then I get to oxygen, which he supplies 64 grams out of the 124 times 100%. So, I'll look at multiply and divide. The first one's going to be 22.58%. Hydrogen supplies 6.45%. Carbon is 19.45%. And the oxygen at the bottom supplies the most, and he supplies 51.61%. Oh, it's not important. Where's that sound? I guess I got an email. All right. All right, we'll go to letter C. So letter C, we got MgOH2. How much time do we got? Hold on 1 second. All right, so we're going to do MgOH2. So I got 1 magnesium, he's 24, plus, oh, there's 2 oxygens times 16, plus 2 hydrogens times 1. So we add these guys up, I got 24 plus 32 plus 2. And you add all those guys up and you get 58. So now I go Mg, he is 24 grams out of the 58 times 100%. Then I got oxygen, he supplies 32 out of the 58 times 100%. And the hydrogen supplies just a little bit, he supplies 2 out of the 58 times 100%. Okay. So multiply these guys out. This one is 41.38%. The oxygen, he supplies big part, 55.17%. And hydrogen supplies just a little bit. He supplies 3.49%. All right. And then the last question. Last one. Yeehaw. So the last one we got is Na3PO4. So this is 3 times 23 plus 1 times the mass of phosphorus, which is 31, plus 4 oxygens times 16. All right, so this guy, this is 69 plus 31 plus 64. Add all those guys up and we get 164. So that means for the sodium supplies 69 out of 164 times 100%. Then we get to the phosphorus, he supplies 31 out of the 164 times 100%. Then I get to the oxygen, he supplies 64 out of 164 times 100%. So we multiply these guys out and we get, first one is 42.07%. The phosphorus, he supplies 18.90%. And the last one, he supplies 39.02%. All right, well that concludes all of them. So we'll see ya. Now don't forget, we're gonna have the test coming up. It'll be really, really soon, like tomorrow probably. So check your Canvas page and we'll see ya.